Okay, we're going to go over the relationship between frequency and period. Before we do that, I do want to go over a couple things, just a couple review things. Okay, so if we have a periodic wave, it looks like this. So remember, the top is going to be our wavelength. So from one crest to the other crest would be our wavelength. The bottom are our drops. Okay, a wave with a high frequency would look something like this, in which the waves are very close together. In other words, high frequency waves have low wavelengths, whereas a wave with a low frequency would have a high wavelength. So wavelength and frequency are always inversely related. When one of them goes up, the other one goes down. Okay, so let's go over again, what is frequency? So frequency equals waves per second. So how many waves pass every second? And the units we use for that are going to be hertz. So hertz is just waves per second that pass a certain point. Okay? And let's remember that period is, which we'll represent with P, period is the time it takes for one cycle. In other words, time for one wave to pass. So time for one wave to pass a certain point. Okay, so you can also think about if we have a wave here, for example, you're in the ocean, we have a wave, the time, if say you have a boat here, the time it takes that boat to go from the bottom, then back up to the top, that's the period. So if it takes 10 seconds to do that, then your period would be 10 seconds. Okay, so just a little bit of review. Okay, so let's go over the relationship between period and frequency. So let's say we have a wave that has a frequency of 1. A wave like this. It's passing a certain point. The frequency is 1 hertz. In other words, I get 1 wave per second, right? Because this is waves per second. So I get 1 wave per second. Well, if I have 1 wave per second, I want to figure out how long does 1 wave take, how long does the time for 1 wave to pass? Well, that's going to just be my period. If I get 1 wave every second, then my period equals 1 second, right? Because it's 1 wave per second. Okay, that's pretty straightforward. All right, now let's say I have a different wave with a frequency of 2. In other words, I get 2 waves per second. Okay, so in 1 second, I would get 1 wave and 2 waves. So now I got to figure out the time it takes for for each single wave to pass. In other words, the time it takes for this wave to pass and the time it takes for this wave to pass. Well, if I get 2 waves in 1 second, right? 2 waves per second. If both of these pass in 1 second, then each of them must have passed in half a second. Because both of them must equal 1 second, right? So this passed half second. So my period equals half a second. And we can just keep extending that. Let's say I have the opposite, in which, or not the opposite rather, but the next frequency in which I have a wave here. I have 1 wave, 2 waves, 3 waves with a frequency of 3 hertz. Well, if I have a frequency of 3, that means 3 waves pass per second. Well, if 3 waves pass per second, then all of these 3 have to pass in 1 second. So each one has a length of, or rather a period of 1/3 of a second. So my period equals 1/3 of a second. So you should start to see a trend here. The next one, 4 hertz, would be 1/4. As my frequency goes up, 1, 2, 3, my period begins to decrease in the same proportion. Okay? In other words, they are what we call inversely proportional. When one goes up, the other one goes directly up in the opposite amount. Okay, so the relationship between that is, if you notice, this is frequency. So if I have frequency here, if I plug that in, it's just 1/2. Frequency here, plug that in, that's 1/3. So the equation that gives us is that my period equals 1 over frequency. Right? Because if my if my frequency is 2, that gives me a period of 1/2, which is what we have there. If my frequency is 3, well, that gives me a period of 1/3. Okay, so that's where this equation comes from. And you can also rearrange this. So if we rearrange this to solve for frequency, we can just go times frequency here times frequency here. That gives us frequency times period equals 1. I want to solve for frequency, so I go divided by P, divided by P. Cancel. Frequency equals 1 over period. Okay, so those are my main equations here. They're essentially the same, just kind of opposites, inverse relationship. Let's go over how to use these in problems. Okay, so I have a couple of problem sets that we're going to work through. They're relatively easy. So here's our first problem set. What is the period of a wave with a frequency of 10 hertz? Okay, well, I know that period equals 1 over frequency. All I have to do is plug that in. So I have 1 divided by my frequency, which is 10. That's going to give me, well, you can leave it like that, but I want you guys to put it in the calculator. So that's just 1 over 10. In other words, we want to go 1 divided by 10. It's going to give me 0.1. So my period is 0.1. Well, period is time, right? How long does it take? We measure that in seconds. Okay? All right. Let's go ahead and go on to the next problem. So the next problem says a wave takes 0.5 seconds to pass a point. What is the frequency of that wave? Now we're looking for frequency. Okay, so I can use the opposite equation. I can rearrange it, but I'm just going to kind of use the opposite one because we already solved for it. So frequency equals 1 over period, right? So I know my frequency is going to equal 1 divided by my period, which is what says a wave takes 0.5 seconds to pass a point. So the time to pass a point, well, that's my period. So I just go 0.5 equals, I just put that in my calculator, 1 divided by 1 divided by 0.5 gives me 2. So my frequency is 2. Well, frequency is measured in hertz. 2 hertz. Okay? So these are just a couple practice problems because I want you guys to be comfortable with practice problems as well as the concept. Okay, let's go ahead and go on to the next one. What is the period of a wave? That's the type word. What is the period of a wave with a frequency of 30 hertz? Same process as we did here. It's easy. Period equals 1 divided by 300 hertz would give you your frequency. In other words, it would go 1 divided by 300, put that in your calculator, it will give you an answer. Okay? All right. Let's go into a little bit more, not a tricky problem, but different type of problem that you're going to see. So this problem says, a man is on a swing that completes 1 cycle every 10 seconds. So we have 1 cycle every 10 seconds. well, we have a couple hints as to what this is. We're looking for the frequency, right? Well, the first hint is it's in seconds. If we're talking about waves, seconds has to do with period. So that's the first hint. That's probably period. Then period is the time it takes for one wave to pass. In other words, the time for one cycle. Well, if one cycle takes 10 seconds, then this is my period. Okay? So frequency equals 1 divided by 10. Right? Because frequency equals 1 divided by my period. Okay? And that would be my answer, which would just be similar to the first problem, 0.1 seconds if we put that in the calculator. Okay, let's go through the last problem, which involves both frequency, period, and also what we did last week, okay, which was the wave equation. So the problem is, what is the period of a wave that travels through a spring at 3 meters per second and has a wavelength of 1.5 meters? Okay, so we know wave speed equals lambda, which is wavelength, times frequency. What do we know so far? Let's list that. Well, I know the speed, right? I know the speed is 3. Well, you won't worry about units right now, but I'll put them in here. I know my wavelength is 1.5. My frequency, well, I don't know that. Okay. Let's see what else we can figure out from this. The problem's asking me for the period, which is strange, right? Because we haven't solved those problems yet. This doesn't give me period. However, it gives me frequency. I can solve for frequency. And if I solve for frequency, well, I can solve for period, right? That's what we've been doing. So we're going to go ahead and solve for frequency. So I'm going to plug this in. 3 equals 1.5 times f, frequency. Divide both sides by 1.5. Divided by 1.5. Cancel. Frequency equals 3 divided by 1.5. 3 divided by 1.5. You can put that in your calculator. It's going to give you frequency equals 2 hertz. Okay, so if you were doing last week's problems, you would be done. But it's asking for period. We know period equals 1 divided by f, frequency. So we just plug in the 2. Period equals 1 divided by 2. In other words, 1 divided by 2 is 0.5 seconds. Okay, and that would be my final answer.